everyone. Good morning. Thank you so much for joining me in this session. My name is Rashmi Dhakar, and I'm joining you from the beautiful city of Fredericton. I'm a recent grad from University of New Brunswick, and today I will be presenting my work on emotional contagion in open source software collaboration. Before I start, I would really like to extend my gratitude towards my mentor, Dr. Ben Vicenti, and the conference organizers and the committee members. Thank you so much for giving me this opportunity to share my work with you. So without further ado, I would like to start. Emotions are complex and an inevitable part of the human consciousness. Consciousness allows us to act according to the situation that surrounds us. But in situations where we cannot comprehend the surroundings, we act on how the situation is perceived by us. Contagion in itself means spreading from one to another. An emotional contagion is an event in which the emotional state or emotions of an individual or group of individuals are influenced by one another. Contagion of emotions can be subconscious or conscious, and in case of subconscious contagion, emotional state of an individual is registered by the receiver, and it can result in mimicry of emotional state. For example, the mimicry of your body language and gesture is while you express emotions is a good example of how subconscious contagion can happen. In case of conscious contagion, the individual is aware of their change in emotional state and therefore reacts appropriate to the situation at hand. This is very crucial in terms of group dynamics, as in such a case, it is very important in case of group dynamics, as in such a case, situations, the affective state of one individual can counter to that of the entire dyad or the entire team. Having serious consequences of changing emotional state, we observe that emotions in software development processes result in different ways, like productivity or the quality of work, the communication amongst members, etc. These consequences, when quantified over a period of time, results in very severe results which are not favorable in the outcome of the development process. So in our previous study, we attempted to detect the presence of emotional contagion in the development environment. This particular study has been based on some of the postulates and hypotheses that have been proposed in our previous study, and you can take a look at it at the end. You can take a look at all the hypotheses that has been presented in the paper in the written work. Talking about the previous study, emotional contagion causes a lot of change in the emotional dynamics of the overall team, and has been found as a group contagion affective tone, and it can affect the work outcomes. Understanding how emotions of one developer can affect the emotions of the entire team is an important and crucial research area. In that particular study, we proposed a simple idea of whether or not emotional contagion happens or by conducting an analysis on commit messages of open source software repository, which can be used by managers and other hierarchical decision makers which can be used by managers and other hierarchical decision makers for a controlled environment. And we performed this particular study based on two methods. One for testing, in which we used a built-in classifier, and in the second method, we used a trained classifier using a training data set. For this particular study, we proposed the model for the detection of the emotional contagion. It's a four-step method in which we first evaluated the sentiment polarity of developers over a period of time. In the first step, we collected our data from GitHub, since it's a comprehensive source of many open source software repository. For the analysis purpose, we use the research software called Wolfram Mathematica, which is a modern technical computing system supporting all areas of computing, be it image processing, data science, neural networks, etc. We use the built-in classifier by Mathematica, after which we use the results by plotting them on a time sequence and used it for answering our research question based on different parameters. So in this study, we worked under the assumptions that the authors or the contributors that we have used in our for our data set do not have any face-to-face interactions where they are aware of the physical cues of the sender or recipient. It is important to stress on this aspect of the data set, as the analysis is purely based on the data set where the above assumption holds true. This study is based on the recorded changes in the software development process, where it is assumed that the perceiver's emotional state prior to being exposed to the expressor's emotional state is neutral. There is no changes whatsoever. As we can see, talking about the results, there was not a big difference between the polarity of negative or positive contagion effects in spite of different demographics. For example, in two of the repositories for VS Code and TensorFlow, we have seen a large number of comments but less number of authors, and still see a huge gap of negative and positive polarity despite being a smaller project. In case of pandas, it has relatively less gap amongst the net negative and positive polarity of the comments. Also, the affective graph of pandas increases after a series of positive contagion episodes as compared to that of big repositories like VS Code and TensorFlow. In this study, we observed for a random 500 sequential data points. We found that there is a long contagion episodes instead of short episodes. In order to capture the contagion, we used multiple instances through which we can deduce the presence of contagion. We also observed that there are a greater number of negative contagion sequences than positive. Also, taking into account for repositories VS Code, there is a lot of varying points at which the curve changes. This indicates that instead of having long episodes of contagion, we can see small minuscule set of contagion activities. Another way to theorize this hypothesis is to look at the sequence of sentiment polarities. The full report of each and every case can be provided at the end of the session, and there is more to look at in the written work. I'm sorry, I'm not able to capture all the possible results and of the data sets in this presentation. If we take a look over here, the sequence cases for the selected data points that I have shown the affective graph for in the previous slide. Through the help of sequence cases, we can see that the general length of the contagion for each commit messages. In order to capture the contagion, we use multiple instances through which we can deduce the presence of contagion. For instance, using pattern recognition to find the patterns where there is a shift in the polarity in the sentiments of the commit messages, because one of the initial message. Through this process also provided us with the results which were more reliable in constructing what we were looking for, but the process was not exactly time feasible. For example, for a very small data set, let's say from 20,000 to 90,000, the time complexity to apply the functionality on the data set and to run it through the machine is more than 2 or 3 orders of magnitude. So instead of doing that, we chose a random set of small data points and from every repository and examined that through different sequence cases. If we can take a look at the affective graph of two of the biggest repository in the data set, we can see that there is a small part of the affective graph for TensorFlow and PyTorch, despite having like really large number of commits and with neutral polarity, and even sequences with really great number of neutral sequences, we see that it's not very significantly affecting the affective graph. Again, the full observation, including the complete affective graph for all the test data set, can be provided at the end of the session. Talking about neutral contagion, one of the key inferences that we came across during our study that concerns us is that an author with a very small number of opposite polarity, for example, negative or positive polarity, We infer that despite being exposed to a contagion episode, the affective curve remained unchanged at mass. Contributors, which tend to have a very major shift in their affective state in the beginning of the week and led to in the end of the week led to greater number of comets in comparison to the weekend when the response is negligibly small, whereas the contributors with greater number of negative responses tend to have more comets in comparison to the contributors whose affective curve lies on the positive side. A complete list of the observation, including different sequences of affective graph and the observed results for the random sequential data points, are listed in the written work, and I can provide you with all of that at the end of the session. I'm sorry, I'm just a little, I'm having a little cough today. In conclusion, these are some of the highlights of this study. From the last two studies that we observed, I would like to focus on the neutral sentiment aspect and the emotional contagion that we observed in case of neutral polarity. Because of its very nature, it is rather difficult at this point to say how neutral contagion affects the development process or whether it is a good thing to have this polarity without having any link to its relationship with a parametric like productivity or quality of work. We found that from our literature review and all the background study that we have done, that positive and negative emotions have some sort of relationship with parametrics like that, but we have found no correlation whatsoever when it comes to neutral sentiments. Overall, this study focused on the following points. I would like to focus your attention towards the first point being emotional contagion and aspect of software development process. We also provided a simple approach for detection of emotional contagion in software engineering. This can be replicated if you want to take another data set of your own for your own organization and replicate this study and see how emotional contagion affects your team and your productivity. And the third being how consequences and reasons behind decision making in software development process happens because of emotional contagion. If we talk about future work, aside from the consequential effect of emotional contagion and merged issues, here are I can tell you some of the key points that we are looking forward to work this year. The first being we are trying to eliminate our first dependency, which is the use of the software Mathematica. For a more refined approach, we are trying to perform the same sort of framework using different approaches and tools which are trained more specifically on software engineering datasets. For example, tools like CentiStrength or CentiStrength SE. We also performed the study and categorized the emotions into 3 categories and analyzed their contagion impact. We are working on developing a more sophisticated framework where all the emotions are subcategorized. For example, joy and happiness and sadness and surprise, etc. And the contagion effect of different emotions that can help us into taking accountable actions which are very specific to a particular individual. Furthermore, we are also working to perform the study in a controlled environment where we get to observe the contagion in different parameters like self-reporting and self-analysis, and the self-analysis after reporting. It means we show the test cases that their emotional effect and then observe how the new contagion effect along different parameters like productivity and quality of work, etc., affects the overall work. And with that, I would like to conclude my presentation. I once again would like to extend my gratitude towards all the people present in this session, and I would like to thank my mentor, Dr. Ben Licenti, and I would take any questions if anyone has any.